The answers, lightning version, we have, you already read it, so you know that it's talking about area. And we find area of a rectangular region by doing the length times the width. So this is a multiplication problem. We have the width of, well, we'll start with the length. Length of 10,000, and we're going to multiply that by a width of 4.8 times 10 to the third. Now, first step, get it into the same type of notation. All right, we have standard versus scientific. You could go either way this time. I'm going to go scientific. This is kind of easy either way. So that'd be 1 times 10 to the fourth, because I'm going to put the decimal there, and that's 4 places away. And I still have that 4.8 times 10 to the third. Now, when we're multiplying, you look at your rules. You can use commutative associative, so it's going to be 4.8 times 1, and I group my powers of 10. All right, I can just multiply by 1, so that's 4.8. And then what do I get when I do this? When I do my powers, it's the product of powers property, so let's add the exponents, which gives us 7. All right, so there we go. It says write our answer in scientific notation, and we have it. Let's just real quick read. It says, what is the area of the land in square meters? So that is, we have to write our units there, square meters. Now, let's move on to the next one. All right, the average mass of a grain of one type of sand is that much. All right, so that's one. We have 1 grain of sand, and there are 1,000 grains of sand in 1 cubic centimeter. What is the mass in grams of 1 cubic centimeter of sand? So, how many grains of sand are in 1 cubic centimeter? 1,000 grains. So now we have 1,000 of those right there. So this is a multiplication problem. We're going to set it up. Multiplication, so it is how much 1 weighs times how many of those things you have. So we have 1,000 of those. It says to give my answer in scientific notation, so I might as well write them both in scientific notation. The first one's already done for us. And the second one we'll write as 1 times 10 to the decimal there, 1, 2, 3, to the third. Now we're ready to use commutative and associative properties. So that's 7 times 1 to group the just numbers, the integers, and then we have the powers here of 10, which we'll group like this. All right, and when we simplify, we get 7 times. Now we simplify this using our product of powers property, and we add the exponents. Negative 4 plus 3 equals negative 1. So therefore we have 10 to the negative 1. And we read to see what our unit is going to be for this, and it asks us for what is the mass in grams. What is the mass in grams? So this is 7 times 10 to the negative 1 grams, which it makes more sense to me in standard notation or standard form, which would be 0.7 grams, just under 1 gram. But it asks for this, so we'll circle that. Next problem, here we go. Number 5, which is actually number 3. All right, read it. There's this much in a drop of water. How many molecules are in 100 drops of water? Very similar pattern to the previous problem. It tells us how much are in one, and then it tells us that we have a bunch of that same thing. So it's a multiplication issue. And we're going to do 0.67 times 10 to the 21st. And we're going to multiply that by 100. Now, we have to write them both in the same, our answers in scientific, so let's do the problem in scientific. Not, mandatory that you do it like that, but I think it's helpful. So 1 times 10 to the dot 1, 2, second. Now it's going to be 1.67 times 1 and 10